In this video, we are going to learn how to find the exact value of various and sundry trig functions given angles in degrees and in radians. Now, to do this, there's some background information that you need to know. And some of it boils down to things that you need to memorize. So, there are three key facts that you simply have to memorize. And then everything else sort of flows from there. So, pop quiz. Let's see if you know the three key facts or not. So the first key fact is, what is the sine of pi over 4? Okay, do you know that? The sine of pi over 4 is 1 over radical 2, which is the same thing as radical 2 over 2. Okay, you have to have that memorized. Just no two ways about it. Now, you also need to know what is the sine of pi over 6. What's the sine of pi over 6? And hopefully you know that is 1/2. Okay, now you also must know the cosine of pi over 6. And that is radical 3 over 2. Now, if you have these three facts memorized, there are a bunch of other facts that sort of fall into place very easily. So the next thing is the cosine of pi over 4. Because the cosine of pi over 4 and the sine of pi over 4 are the same thing. So this is also 1 over radical 2, or radical 2 over 2. Now the reason why, the next thing you need to know is what's the sine of pi over 3. Okay, and we're going to need to know what's the cosine of pi over 3. Now the reason why this wasn't something that we had to memorize on its own is because of the way that these are going to be just the reverse of what we got from the pi over 6 questions. So these are just going to be reversed. So the sine of pi over 3 is going to be the radical 3 over 2. And the cosine of pi over 3 is going to be the 1/2. Alright, see how they kind of just switch places. That's why you don't really have to memorize them all over again. Okay, and once you have that, then we can talk about tangent, which is also something you need to know. What is the tangent of pi over 4? What is the cosine of pi over 4? We're doing tangent. What's the tangent of pi over 4? What is the tangent of pi over 6? And what is the tangent of pi over 3? And you don't have to memorize these. You just need to know that tangent is sine over cosine. So we have the sine and we have the cosine. So in this case, these are both the same. If you divide something by itself, you get 1. Alright, so the tangent of pi over 4 is 1. What about pi over 6? Well, if you divide this by this, notice how the denominators are the same. They're going to cancel each other out. So that's going to give you 1 over radical 3. And that's the same thing as radical 3 over 3. And for this last one, again, sine over cosine, the 2's cancel out. You have radical 3 over 1, which is just radical 3. I feel like I should space this out a bit. Alright, now each of these are special angles, and I'm showing them here in radians, but you should be able to know what they are in degrees. So for example, pi over 4, you need to know that we are talking about 45 degrees. Alright, so all of these pi over 4s, we're talking about 45 degrees. Pi over 6 is the same thing as 30 degrees. All right, so if I ask you what's the cosine of 30 degrees, you have it, radical 3 over 2. And pi over 3 is 60 degrees. All right, so you should be able to generate a chart like this in like a minute and a half. So if you have to take a test or a quiz or even just do a homework assignment, the first thing you should do is take out a half sheet of paper and generate this chart. All right, and then we will use this chart for the rest of the test. Now, when they ask you to evaluate some function, ask yourself what the reference angle is. So 135 degrees, okay, the reference angle is 45 degrees. Okay, so the beauty of a reference angle is that the value of a trig function at the reference angle is going to be the same as the value of the trig function at the original angle, with one exception. It might be positive or it might be negative. So this is going to equal the cosecant of 135 degrees, except for maybe it's positive, maybe it's negative. All right, we'll have to figure that out later. Now, what is the cosecant of 145 degrees? Well, you need to know that cosecant of any angle is the reciprocal of the sine function. All right, it's the reciprocal of the sine function. So let's work backwards. Let's ask ourselves, what is the sine of 45 degrees? Okay, so well, the sine of 45 degrees, that's one of the things that we have memorized. That is radical 2 over 2. You know what? Let's go ahead and use the 1 over radical 2 version because it'll be easier to do the reciprocal. So the sine of 45 degrees is 1 over radical 2. Okay. So what's the sine of 135 degrees? Okay. Well, it's either going to be positive 1 over radical 2 or it'll be negative 1 over radical 2. So let's look back at our sketch. See, we are in the second quadrant. Is sine positive or negative here? Now remember that sine is a y value on a unit circle. So in this quadrant, in the second quadrant, the sine function is positive because y values are positive above the x-axis. So this should be positive. So that means that the sine of 135 degrees is positive 1 over radical 2. All right, which means that the cosecant will also be positive. Okay, so now we're ready to answer the actual question. So the cosecant is the reciprocal of the sine function. So that just means I will have to take this and turn it upside down. So that's going to just be radical 2, positive radical 2. All right, and that's it. All right, let's practice that some more. All right, so number 14 is given to us in radians. So again, the first thing you want to think about is what is the reference angle? Well, in radians, it's easy to see what the reference angle is because it's like right here. The reference angle is pi over 4. So, in terms of doing my sketches, this is what I like to do. If I know the reference angle is pi over 4, then what I do is I draw a bunch of pi over 4s. So pi is the top half of the circle. So if I split it in half, now I've got pi over 2. If I split it in half again, all right, then I'm dividing pi into 4 equal pieces. So that means each one of these sectors is pi over 4. So looking at the angle that we're given, 3 pi over 4. Well, this is 1 pi over 4, 2 pi over 4, 3 pi over 4 is right here. So, the question is, what is the cosine of the reference angle? So the reference angle is pi over 4. So let's focus on that first. What's the cosine of pi over 4? Well, again, that's something that we have memorized. Okay, the cosine of pi over 4 is radical 2 over 2. Okay, so fine. That means the cosine of 3 pi over 4 is going to either be radical 2 over 2 or it'll be negative radical 2 over 2. So to figure out whether or not it should be positive or negative, we just look at the quadrant. So is cosine positive or negative here in the second quadrant? Now remembering that cosine is an x value, all right, an x-coordinate on the unit circle. That will help us know in the second quadrant cosine should be negative because x values are always negative to the left of the y-axis. So cosine should be negative. So that's why we know that instead of being just radical 2 over 2, the cosine of 3 pi over 4 will be negative radical 2 over 2. So that is the value of the cosine. So again, just to summarize what I just did, if you want to find the value of a trig function, first find the value of the reference angle, and then look at the quadrant it's in to find out if it's positive or negative. Okay, let's keep going. 11 pi over 6. So obviously the reference angle is pi over 6. So that's what I'm going to figure out then. I'm going to figure out what is the secant of pi over 6. So let's draw it. All right. Since the reference angle is pi over 6, I'm going to draw a bunch of pi over 6s. So that means I need to somehow take the top half and divide it up into 6 pieces. So watch how I do that. All right, see how I have 3 pieces here so far? Okay, so just looking at the top half, which is pi, I've split it into 6 pieces. So that means each one of these is pi over 6. So anyway, this is 11 pi over 6. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6 is right here. Okay, in the fourth quadrant. So now let's go ahead and solve this thing. Well, secant. You have to remember that secant is the reciprocal of the cosine function. So I'm going to start by asking myself, what is the cosine of the reference angle? What is the cosine of pi over 6? And that's one of those things that we should have memorized. Cosine of pi over 6 is radical 3 over 2. Okay, so fine. In that case, what is the cosine of the original angle 11 pi over 6? So remember, the cosine of the reference angle should be the same thing as the cosine of the actual angle, except maybe this will be negative. So I know that the cosine of 11 pi over 6 is going to either be radical 3 over 2 or negative radical 3 over 2. To know whether it's negative or positive, just look at the quadrant. Is cosine positive or negative here in the fourth quadrant? Well, cosine is positive in this quadrant because remember that cosine is an x value on the unit circle. So, since cosine is an x value, x values are positive to the right of the y-axis. So, that's why we're going to go with positive radical 3 over 2. And finally, now we're ready to say the final answer. What is the secant of 11 pi over 6? Well, the secant is just the reciprocal of cosine. So if cosine of 11 pi over 6 is radical 3 over 2, then the secant should be 2 over radical 3. All right, I just did the reciprocal. You could also rationalize the denominator, and that would become 2 radical 3 over 3. But for me, you can just leave it like this. Okay, what is the cotangent of 5 pi over 3? Well, let's talk about the reference angle. So the reference angle is pi over 3. So let's start off by asking ourselves, what is the tangent of pi over 3? Okay, now, the tangent of pi over 3 is one of those things that we should have been able to figure out. It's one of the things on our chart. Tangent of pi over 3 is radical 3. Okay, so great. So we know the tangent of pi over 3 is radical 3. Now, what is the tangent of 5 pi over 3? Okay, now the tangent of any angle should be the same thing as the tangent of the reference angle, except maybe it's negative. So we know that the tangent of 5 pi over 3 is going to either equal radical 3 or it'll be negative radical 3. To know whether it's positive or negative, we should look at a picture and see what quadrant it is in. Let's see. So I see the reference angle is pi over 3. So I'm going to draw a bunch of pi over 3's. So I'm going to take the top semicircle, which is pi, and divide it up into 3 pieces for pi over 3. So that would look like this. Alright, you see how I've taken the top half and now it's 3 pieces? That means each one of these is pi over 3. So 5 pi over 3, so this would be 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3 is right here. Okay, and just to make it extra clear what quadrant we're talking about, here's the y-axis for you. And the x-axis. Alright, so clearly this is here in the fourth quadrant. So is tangent positive or negative here? Well, I hope that you have memorized somewhere along the way that tangent is positive in the first quadrant and in the third quadrant. Tangent is negative in the second quadrant and the third quadrant. Alright, that's worth just memorizing. Okay, so I know that this should be negative in this particular quadrant, so that's how I know that this will be negative radical 3. Okay, now we are ready to say the final answer, cotangent. Alright, they asked us about cotangent, but we know that cotangent is just the reciprocal of tangent. Okay, so if tangent of 5 pi over 3 is negative radical 3, then the cotangent will be negative 1 over radical 3, the reciprocal. And if you rationalize the denominator, you're going to get negative radical 3 over 3. Okay, but this is good enough for me. Number 17 will be a little bit different, but easier, because negative pi is a quadrantal angle, meaning it lies on one of the axes. It doesn't fall in a quadrant. It falls right on either the x-axis or the y-axis. So that's called a quadrantal angle. So technically, this is a negative angle, which means we should be looking at it as a clockwise motion. But either way, really, no matter which way you went, you're going to end up here. So negative pi is right here on the negative x-axis. So there is no reference angle, so we're going to think a little bit differently. So instead of talking about reference angles, we're going to just talk in terms of coordinates. So the coordinates at this point are -1, 0. All right, keep that in your head. Now, on the unit circle, the x-coordinate is the cosine of the angle, and the y-coordinate is the sine of the angle. So we have the cosine and we have the sine of negative pi. So secant is one of those reciprocal trig functions. So secant is the reciprocal of cosine. So let's ask ourselves, what is the cosine of negative pi? And then we can talk about the reciprocal of that. So the cosine of negative pi is -1. Okay, so in that case, the secant should just be the reciprocal of that. And the reciprocal of -1 is still -1. Okay, so that's the final answer for number 17. All right, number 18. So we have a reciprocal trig function, and we're back to reference angles again. So what I recommend is when you have a reciprocal trig function, go back to the basic trig function first. So cosecant is the reciprocal of the sine function. So start with the sine function. The reference angle of -2 pi over 3 is just pi over 3. So start with the original trig function and start with the reference angle and work your way from there. So what is the sine of pi over 3? That is one of those things that we wrote down on our chart. One of those things that we basically have memorized, which is radical 3 over 2. Okay, so sine of pi over 3 is radical 3 over 2. So next, we have to get away from the reference angle and get back to the actual angle that we want to know about. So what is the sine of -2 pi over 3? And the thing is, the sine of any angle is going to be the same thing as the sine of the reference angle, except it might be negative. So to figure out whether or not this will be negative, we need to know what quadrant this angle is in. So I like to just draw it. And since the reference angle is pi over 3, I'm going to draw a bunch of pi over 3's. All right, pi over 3 is 1/3 of a pi, so that's why I'm taking the top half of the circle and dividing it into 3 equal parts. So each one of these positions is pi over 3 as I move around. Now, this is actually -2 pi over 3. So I'm going to move in the clockwise direction because this is the negative direction. So this is -1 pi over 3, and this is -2 pi over 3. Alright, so just to make it extra clear what quadrant we're in, I will go ahead and draw the y-axis for you. Okay, so obviously we are in the third quadrant here. So is the sine function positive or negative in the third quadrant? Well, remembering that on the unit circle, the sine function is a y value, then I know that this should be negative in this quadrant because y values are always negative below the x-axis where this is. So this should be a negative radical 3 over 2. Fine, so now we're ready to say the final answer, because cosecant is just going to be the reciprocal of sine. So if the sine of negative 2 pi over 3 is negative radical 3 over 2, then the cosecant should just be the reciprocal of this. So it should be negative 2 over radical 3. And if you wanted to rationalize the denominator, you could. That would be 2 radical 3 over 3. And that is going to do it for this video. I hope it was helpful. The next video is going to be about, what are we finding? Oh, we're going to find the value of the trig function given a point on the terminal side of the angle. Alright, so if that sounds like something you need to learn about, I will see you on the next video.